Okay, welcome to Getting Down and Dirty with Mac Imaging. I'm really excited to be giving this talk because I don't see a lot of this being talked about these days. The focus of this is going to be a lot of different tricks to getting data off of Macs. So I'll talk a little bit more about that in a minute. Also, accessing data. It's just going to be kind of a random mix of various techniques. So not like one particular theme other than getting data off the Mac. So a little bit about myself. My name's David Dim. I work for KPMG. I've been with KPMG about 5 years. I've been doing digital forensics and incident response for 17 years. Shout out to Dave Cowan, who got me to switch into digital forensics way back in 2007 when I was in industry and I wasn't very happy in my job. So I switched and decided to do something new and haven't really looked back since because it's a lot of fun, right? Little disclaimer, this is research. There's no warranty here. This is my own opinions on some of these findings. So use them for what they are, validate them. I like to be proven wrong or for somebody to find a better way to do things. So this is really just to get the conversation going, get it into the current zeitgeist, get people talking about it again. A little bit more about why I'm giving this talk. I work at KPMG, of course, and we get a lot of Macs. I think over the last 2.5 years, my team's had to image over 100 Macs. I'm probably underestimating. It could be 200 or more. It's been a lot, and we run into a lot of challenges. They're, for lack of a better word, a pain in the butt. And I'm sure some of you can relate if you've done Mac imaging in the past. Basically, as I was saying before, I haven't seen a lot of new research, a lot of new techniques for getting data off of them. And when I say getting data off, I'm not necessarily mean like a full disk image. I just want to put some stuff out there that'll spur some enthusiasm. And then the other problem we have is you have to use dongles with commercial tools, and it gets expensive when you have people all over the country. You're going to client sites, you're shipping a dongle, and having to use the tool on site. You have to ship the person, the tool, the client has to pay for it. They may or may not like it. If you're working inside a corporation, you have to ship something there if you want to get a full disk image. Good luck explaining to a user how to image their own Mac. Nor should you, because they're likely to brick it or do something else to it. I'm really going to stick my focus to Apple Silicon, the M series, the new stuff. Although most of this stuff will work on Intel T2, doesn't matter. Not going to cover every scenario that could come up, but I am going to cover a little bit about getting data off remotely. You know, the traditional view of imaging when I started doing forensics way back in the olden days was DD and FTK Imager, and I was running Helix or Smart Forensics from Andy Rosen. And we were doing it on Windows machines, and it was a bit-for-bit copy. The disks usually weren't even encrypted back then. So you'd either pull it, right block it, image it, or you'd live boot into Linux. You could still do that on Windows, right? You can use Paladin. Then if you have a BitLocker recovery key, you can just decrypt it after the fact if you want, or decrypt it right then and there. But when you're dealing with Macs, it's different. You can't do that. It's just not as easy. There's a lot of protections in place. A lot of data is locked down. And you're really limited to the two main commercial tools right now. And things break, even with the commercial tools, which are really good. I'm talking about like Digital Collector and Recon ITR. Things are still going to break. Apple's putting out a new major release every year. And usually when the new major release comes out, something breaks. So I'm going to talk a little bit about the commercial tools, just a little bit about them. I'm not going to go deep because what I want to talk about is getting data off without having to use a full bootable third-party tool. I'm going to talk about live collections, techniques, and then talk about confirming the data a little bit. And then the last but not least is kind of a fun little walk through accessing HFS, APFS disks and the images that are on them without any third-party software in Windows and Linux. So let's talk about the commercial tools. You have Digital Collector. It's a fantastic tool. We use it all the time. But what you have to do is you have to have user credentials or a recovery key for File Vault. And you have to, what happens if you're not familiar with Digital Collector? You get a dongle with the software installed, you plug it into the Mac, you go to the boot menu prompt by holding down the power button on Silicon. You boot into it, and you have to unlock the disk. And what you're presented with is a synthesized disk, which is the unlock representation of the encrypted File Vault disk containers. And from there, you acquire it. You could acquire it, the physical, fully encrypted, but varying, I'm not the best expert on this, but I know a lot. I know enough to know that it's not a good way to go because you may not be able to decrypt it later. So it's best to do the decrypted synthesized disk. And in Digital Collector, you're going to use AFF4 format. That's really your only option. And it's a great format because a lot of tools support AFF4 now, and it's a true forensic container. The only downside with that tool is sometimes there's a slow update cycle. Sometimes it's 3 months, sometimes it's 6 months. But I assume it's because they're doing a lot of rigorous testing and a lot of work because the tool, when it does work, it works really well. Recon ITR is another really good tool that we keep in our tool chest. We use it quite a bit as well. Similar to Digital Collector, you have to boot into Recon, and you're going to unlock the data. When I'm saying unlocking the disk, it's really unlocking the Macintosh HD data partition. That's where all your fun stuff's stored. Now, the difference between Recon and Digital Collector is that Recon uses native formats. It uses DMG and sparse image. And those are good. Sparse has a little less support, so you're kind of limited in the tools you're going to be able to use. And it would be nice if it supported AFF4, but at the moment, DMG is really good. The downside with DMG is that it's big and it's slow. And I don't know about any of you that are doing Mac collections, but typically when I send somebody on site, and I have a team of people, I'm a director, I'm not usually going on site, I'm too expensive. We get told kind of the time window we have to get the job done. So when you have a time window, you want to be fast, but you want to be accurate. So if you're using Recon ITR, you're going to do sparse because you need to get it done fast, and sparse is fast because it's only allocating the space that it needs in the container for the active files and the unallocated that it's collecting. DMG is better because it'll work in pretty much any tool, but in our testing, like our practical results, it's 50% to almost 56% slower on average. So something that might take 2 hours with sparse could take 6 hours. It's just, you just don't always have the time. So you have to have a plan in place to then make a working copy, make a conversion, unless you have Inspector handy or you have another tool, which I'm going to talk about in a minute. Both tools do live collections really well, and I'll talk some more about that in a minute. There are some limitations, obviously, when you're booted into your Mac and you're running these tools, even with admin privileges, there's some things you can't get at. So do we have issues? Yes, we always have issues. You might be running into MDM issues, or if it's a T2, you might have a device security lockdown that's been implemented. Sometimes you have OS compatibility issues. You might have a firmware password in place on the Intel ones. I haven't run into it yet on the Silicon. I'm sure it'll come along. And then sometimes you just have an issue. Like I was saying before, like we have a new version of macOS that's imminent. When that comes out, I'm going to assume something's going to break again. So that's why we have a tool chest. We have multiple tools. So what I'm going to talk about now is snapshots. And some of you are going to be like, snapshots? Like what? It's Time Machine. Time Machine's been around since I think Leopard or can't remember the exact version, but it's been around a really long time. And it's kind of been forgotten a little bit, but it's actually still there. It's a lot like, kind of reminds me of volume shadow copies, very similar concept where you're taking a delta of the disk and you can take multiple deltas. But we can use them in a different way. So let's dig into this a little bit more. So there's a few caveats, right? You still need system credentials. You have to boot into the system to access the snapshot, to create a snapshot. Terminal needs to have full disk access. There's just no way around that. Full disk access. If you try to run it without setting it full disk, you're going to get permission denied or something like that. By default, Time Machine in the documentation says it excludes certain paths, but the way that we're going to be dealing with snapshots, it hasn't really been a big issue. I'm hoping somebody will try to prove me wrong on that and do some diffs and deltas that show that there is maybe something missing. You're not going to get unallocated, but that's honestly in this, for what I'm going to be talking about, it's not really a big deal because the disk is encrypted. The way APFS works, it's, you know, correct me if I'm wrong, I don't usually get a lot out of unallocated. So a little bit more about snapshots. Digital Collector and Recon, of course, both do live collections. Digital Collector actually supports in live collection mode, when you're running it on the system, it can see the snapshot. And so you can collect data from the snapshot. You can even, I think, right click and export it out as an image, which will be really nice in a minute when I get to that. So you have a couple different methods to collect data. Pretty confident you can collect data remotely by just copying it off. I'll talk about that some more. So you can copy the data. There's Apple System Restore. And then if you're crazy and you just want to do old school Time Machine backups, you can do that as well. There might be a use case for that. And then I'll talk a little bit about shared disk. So this is going to be a little bit prescriptive because I wanted to put it into the presentation as a little bit of a how-to so people can kind of walk through this that are familiar with Macs. Try it out, try to make it work. Feel free to bug me if it doesn't work and I'll help you through it. And then find ways to do it better. So first what we're going to do is we need a drive. You're going to plug it into your Mac. You can format it HFS, exFAT, or APFS. A lot of people like to do exFAT. It'll work, but exFAT sometimes is a little finicky and slow. I prefer to do HFS or APFS. Stick with the native types. So then you're going to create a target container. And when I'm talking about, it's a target image, it's a sparse or a DMG. And you're gonna create that on that external drive that you have mounted. And you could use HDI util create, or you can just do it with disk util. It doesn't really matter. It just needs to be mounted after you've created it, mounted read write. So now we're gonna go through creating a Time Machine snapshot manually. So you're gonna run tmutil, Time Machine util, local snapshot whack. That's telling it at the root, create it for this volume. And it's gonna create a Time Machine snapshot. And then you can list the snapshots by doing tmutil list local snapshots whack again. You might have more than one snapshot. You might even have a pending update that you could potentially use because the updates create a temporary snapshot until they're installed. And what these are deltas. So you've created the snapshot, and then anything you do going forward won't show up once you've mounted the snapshot and you get the data from it. So that's really nice too. So now we're going to mount the snapshot, and this is kind of the magic. Props to Nicole Ibrahim for figuring this out. She came across this because her phone was stolen, and she wanted to get it some Find My telemetry that I think was locked down or something. Long story short, she figured out how to mount the snapshots, got at the telemetry, and actually even after her phone that had been stolen had been wiped, she was able to observe that it was still sending telemetry through Find My and track it down and get that information to the local police. And they eventually did capture and arrest the thieves. So to mount the snapshot, you need to create a temporary mount point. We're going to do it in TMP. We're going to call it Snap. We don't do it under volumes because volumes typically will expunge a directory that's just sitting there that you've created. You can do it, it'll work. You could even put it on the target drive. You can create a little snap directory on there and mount your snapshot there. It doesn't really matter where. You'll run mount APFS. What's really important here is that you pass in the read-only option, no owners and no exec, because you really don't want to be running binaries from your mounted snapshot unless you're an adversary. Then you're going to pass in this -s. So let me go back real quick. You see here where we listed out the snapshots. Copy that to your clipboard or whatever, write it down. That's what you're going to feed into this -s, which is snapshot. And then you're going to provide it the source, which will be system volume data, not the actual device ID. And then you're going to give it a mount point, which is TMP snap. And then it should work. Make sure you're doing it with sudo privs in a terminal that, like I was saying, has full disk access. And then to validate it's mounted, well, you won't get an error if it's mounted properly, but df-h, you can see it listed. And then that's where the magic begins, because you've mounted a snapshot of your running disk with no limitations, essentially. So when you go to users, downloads, desktop, documents, you're not going to get a pop-up. You can run your collection tool. You can do your triage. You can do whatever you need pretty much anywhere within that mounted snapshot without any limitations. So a lot of this is new research. We've only figured it out, her phone was stolen about a year ago, I think, and we just kept talking about it, and I kept testing, and she was testing, and we've come up with some ideas on how to make all this work. And I think this could really be good for people that need to do triage for IR, other types of needs, e-discovery, whatever, because now you don't have to do a full disk. So a couple strategies for copying data off. So again, you're going to be copying from the mounted snapshot to your mounted image on the external drive. And so once you are done and you unmount that, you have an image or whatever. I like to call it a container. So you're going to run. So ditto's one option. The capital X just keeps it from crossing device boundaries. So you don't loop into the volumes directory and start grabbing your mounted disk as well. And then I've got a couple commands to clone and try to keep some of the extended attributes from the file system for the files. And it's going to nuke whatever's in that mounted snapshot. You can also use rsync. Rsync's a really good tool because not only will it copy the data, it'll delete anything sitting in your mounted container. It also has a lot of other features, right? You can do SMBFS, you can do, you can send data off over the network. Or if you don't need those things, you just need to collect a few files, tar it up, zip it up, whatever, you're not going to have any restrictions. So yeah, remote collections with snapshots are possible. The downside obviously still is you still need terminal running with full disk access. So you want to do a remote collection, you could do a screen share with the user, you could VNC to it. You might have an agent on there that you can set up an interactive session. I don't know, but I think there's a lot of possibilities there. So again, Joe Schmo over here has a laptop. You need to get the data off of it. You don't want to ship a dongle or a person out to, wherever. You can mount the snapshot. You could create a local DMG or sparse on the disk after you've created the snapshot. Or you have them plug in an extra hard drive. Or you could try to mount a remote file system and just set up a container there and copy it over. So I think there's a lot of possibilities here. Haven't tested all these scenarios fully, but I think it's all very doable. There's a few links at the bottom related to MDM. Nicole found these recently. These aren't tested at all, but there are some policies you can push to the Mac according to the Apple documentation and the developer documentation, where you could either push a profile to maybe remotely configure the terminal app, or push a MDM profile to remotely configure the terminal permissions. I'd love to see somebody write a blog on that for me. I only have so much free time, right? So let's talk about another subject, which is Apple System Restore. When I started trying to test this, it kept failing. I couldn't figure it out. I'd pretty much given up until a couple days before the slides were due. And then I remembered that there was another scenario I hadn't tested for, which is lowering SIP. So once I did that, it worked. So Apple System Restore has been around a while too, and it will allow you to clone your drive, essentially the active files on your drive, to another drive. So we can use it in a slightly different way, right? And we can use it in your regular booted Mac or in recovery mode. That's also really cool. So you got to go into recovery mode, disable SIP, well, you can disable it from the running system. So let me back up a little. What we're trying to get is that Macintosh HD data partition. So what I would recommend doing if you're going to go through this procedure is you have your system running, you create a snapshot, like I showed you before. You run CSR util disable, reboot into recovery mode, and your snapshot will persist. So now you're in recovery mode, you have a snapshot. You have to do a few things first. You need to mount the data partition and unlock it, and you have to provide credentials for that. But once it's unlocked, you can move forward. The difference with this snapshot, accessing the snapshot this way, is you have to give it the ID for the snapshot. So from your terminal app in recovery mode, you're going to run disk util apfs, list snapshots, and then the disk number for the data disk. And it's going to give you the snapshot information. You need that ID. That's the very first top of the tree. And I apologize for not having a screenshot of that. So you do ASR, restore, you give it the source data partition device ID name, number. To snapshot, which seems a little backwards. You would think it would be like from snapshot, but that's just how it works. It says to snapshot. And what it's going to do is it's going to do that delta, that snapshot. And then you give it the target, and then feed it in no personalization, which I think I'm missing a hyphen next to no, and then erase. And erase means it's going to nuke whatever it's being cloned to. So what you can do here is you can have your external drive plugged in. You can have a sparse or DMG already on it, mount that, and then clone the data into that container. And you have an image of your drive. And it actually looks pretty good. So this is what the command output looks like when it's running. And then when it completes, it takes a while. I've done it on a couple of different Macs. I did it on my 1 terabyte Mac and it worked. It just took a while. So you'll get this replicating, restored to target, remounting the target volume, done. It's a nice little output. You could save it. And then you want to throw it in, the DMG into FTK Imager just to take a look at it real quick. And this is what the file system looks like. You get the EFI system. Your disk image is what it calls it. And then you don't get unallocated, but you do get the unpartitioned space, which is really nothing there. If you want, you can do a time machine backup. I don't know why you would, but you could plug a drive in, use TMUtil to set a destination and a mount point, start your backup, and then when it completes, you can gently, do the proper removal of your drive, set everything back to the way it was, and you have a time machine backup, which a lot of tools can process time machine backups. I'm going to talk briefly about shared disk. I have a little more testing I want to do around this, but basically it works. ASLA, Apple Silicon Logical Acquisition, is a newer capability that the Apple Silicon, the M series, now uses. It replaced target disk mode from the old Intel systems. and it utilizes sharing of the disk. So what you do is you boot into the recovery mode and you can click share disk. And from there, you just need to have a USB-C data cable, Thunderbolt, whatever, to another Mac. And it'll share it as a drive on the other Mac. It has some limitations. What I found is I didn't find FS events or Spotlight. I'm wondering if I were to disable SIP and do that, if it would provide me different data. I haven't tested that scenario. I'm hoping that that's the case. There's an ASLA script. I've got a link to it below. Somebody's written a nice little bash script that can automate that process of collecting it and creating an image of it into a, I think it's a sparse or a DMG. Really cool. So let's talk briefly about confirming collections. I'm a paranoid person. I've done so many collections that have gone wrong, or so that have gone wrong for somebody. It's fine that the system says it acquired data and it verified it, but I want to know if the system can, if we can parse the file system. So if it's a DMG or sparse, you can verify it by making a forensic working copy. You could mount it read-only on another Mac. You can use Inspector. If it's AFF4 DMG or Expert Witness, of course, you can use FTK Imager or a number of other tools. But what's really cool is Yogesh Khatri's got MacApt out there. We love to use MacApt. It's free. It's multi-platform. It will handle DMG, sparse, AFF4, Expert Witness. He's using libtsk3 in his scripting, but he has a handler for sparse in there, which is really cool. I'd like to see all that go into the main repo so that TSK supports sparse everywhere, if it doesn't already. So it does good logic checks. So let's say you're in the field, you're in a pinch, and you need to just confirm your image can be read. You can run MacApt against it and see if it errors out. If it errors out, you might have a problem that you need to research. You might have to get a new image, or you can just go to another tool and double check. But a lot of times we're in a time crunch just to make sure we have a good collection. Reading images without a Mac. This is a fun little thing I was doing. You can use Windows subsystem for Linux plus FTK Imager, or you can do FTK Imager with Arsenal Image Mounter to get it an APFS or HFS drive without having to install any other third-party software. Unfortunately, sparse, you're kind of out of luck. You're going to need to convert it or use Inspector, or you can use MacApt, of course. I love MacApt. It's great. So here's a little guide on accessing using Linux, Windows subsystem for Linux plus FTK Imager. You open up PowerShell as an administrator. You run git cim instance query. You're pulling the Win32 disk drive. You could do that with FTK Imager or other tools as well. Then you just need to attach it to the subsystem for Linux. You can just do that with WSL mount, give it the physical drive, and --bear. And then you can run in Linux lsblk. It'll give you your block devices and partitions. And here we see that STD2 is 465 gigs. So that has to be the one that I want. So in this example, I've already downloaded and compiled FS, APFS mount, but that will actually mount it in the Linux environment. I was using Kali. So I'm going to mount dev dd2 to a folder I've created called target physical 1. The critical thing is you need to pass in $X allow other. That allows other users and processes to get at that mounted location. And then from there, you can just browse and explore to the mounted partition. And then you could do what you want with FTK Imager. You could then mount the image there, copy it out, That'll work for APFS. For HFS, you have to do it a little bit different. And then this one's really fun. With Arsenal Image Mounter, you can use virtual DD, which is a really cool, fun feature. And it'll just loop through all the devices, physical disks and partitions on the computer, create a fake drive with all of the a raw image representation of each of those. And I'm pretty sure it's using the Docan driver, which has been around for a while. And then from there, you've got a raw DD representation of your HFS or APFS partition. You know, the forensic tools can read that. So you can use FTK Imager to then mount it, or open it in FTK Imager, export out your image. You can then mount your image on top of your mounted drive image and just process it live or pull out the data you want. So this is what it's going to look like, you know, with it all mounted. You know, you see Macintosh HD data in Explorer. So it takes a lot of hassle out of all of it. And all this stuff's free. And that's really all I had. I wanted to give a big shout out to Nicole Ibrahim because without this, without her research on snapshots, I couldn't have put the rest of the presentation together or had the ideas on a lot of this other stuff. And she's just an amazing Mac examiner. So that's really all I have. Thanks.